Move over Frankenstein, Hollywood and sci-fi absurdities. The 22nd century is right here, right now. Now what could be man's or woman's, if you like, next big discovery or invention? Something to top penicillin perhaps, the transistor, DNA, or indeed the internet, which we're on right now. Nobel Prizes up the yin-yang. Well, during the 2018 Golf Industry Fair here in Bahrain, a fairly large stand was present with nothing on it but a few banners. It was missed by many, to be honest. It was the Nupower Development Bahrain stand, and it was parked next to several other stands displaying heavy-duty electrical cables, which are manufactured in the area, of course. Solar panels and so on, it was all there. Now, the irony of this is that Nupower claimed to be able to transmit electricity around the entire world as if by complete magic, using absolutely no cables whatsoever. Let's refer to it as wireless wave power for now.
We're talking about transmitting electrical power and exporting it over any distance and reconfiguring into power into that regional market or that specific location.
Now, when you say any distance, explain that.
The distance is worldwide, so actually distances become synthetic in the technology. Even though you have the actual distance between the generating point, the launching of the probe, and the receiving, it's the wave encompasses the Earth, and so therefore you're able to extract the energy from any location on the Earth where you have a receiver.
Power or electricity as much as we desire, sitting right here on Earth, available absolutely everywhere and anywhere. It's invisible, no barriers, no shock, no cancer, no idea it's even there beneath your feet and all around you. Even more bewildering, how on earth do they do it? Now stay with it, this is a news item, but it's quite technical, and we'll try and make it as interestingly easy as we can, but that process in itself is not going to be easy. But by the end of this video, you're going to blow your mind. The WhoDoesWhat.tv stand was also next to the Nupower stand, and we noticed that for most of the exhibition, nobody was on their stand. Now, with a uni qualification in propagation, yours truly did his best to explain the process to puzzled visitors who curiously inquired as to how this is possible. Yeah, exactly. Many look at you with ridicule and utter disparaging expletives to the contrary. The process is still commercially top secret, and we're not going to find out how this is done during this video. Furthermore, at the end, you will probably be doubting every single word spoken, and we might not be right. I'm just guessing, simply because Nupower are not telling us. Now, Nupower Development in Bahrain represent a huge American power transmission company called Texzon. Now, Bahrain could be one of the very first countries in the world to use wireless wave power. In fact, way back in February 2018, that's this year as the recording is, His Majesty King Hamad announced that Bahrain will be powered this way, without wires. No more huge pylons scattered across the countryside, or fat underground cables. Now you boil your kettle in the kitchen with power fed from a power station, maybe hundreds of kilometers away. Of course, not on a small island like Bahrain. The cable breaks, you have no power. They fix it. But what if we receive power using no wires at all, by wireless, which, it's not 96.5 FM stereo type wireless, but it is wireless in the form of no wires whatsoever.
Yes, it's difficult to explain, but it is something I think that the layman has been expecting to come for some time. We have wireless phones, we have wireless internet, we have all kinds of wireless things. So the wireless power that we're talking about is something that's been always on the horizon, always something that people have been looking for to occur. It's just now is here.
If you were at the top of Mount Everest and you wanted to boil a kettle or stick on a 2-bar fire to warm your tooties up, then that technology is apparently with us right now. As long as you know how to unleash it, that is, or better still, let's say, tap into it. That is as difficult and secret as it is launching the wave on Earth in the first place. This is as close to real magic with no tricks as the human race is going to experience without discovering another physical but invisible dimension. Now hold on to that thought, because it would seem that whoever discovered or developed this process has literally discovered how to access another dimension or physical phase that we in our own dimension, here and now, and phase of energy cannot see, feel, or touch. Now, the talk at parties after a few, you know what it's like. Do you think there are other worlds out there, zillions of other worlds, in a different phase or dimension, right beside us, but we can't see them? Well, just maybe this process is tapping one of those and actually electrocuting another world that we can't see. Well, that's just a thought, maybe a little hi-fi, but think about it. In the true sense of the words, it is literally incredible, unbelievable, fantastic, and whatever other adjective English speakers abuse in exaggeration, except maybe journalists. But here we are, using those very words as fact. Now don't get confused with milliamps of mobile phone charging by Wi-Fi. That is wireless, as in radio waves. This is wireless, as in no cables, pumping thousands of megawatts around the world.
You do think differently in this. It is radio frequency, but it is a different waveform. It follows Zenneck Wave form, which was done by a German physicist in 1907. And so so the theory about it and the math and the physics has existed since they were doing those type of studies in the early 1900s. It's just now has been developed so that the wave can be launched, which was the most difficult part, was launching a Zenneck wave over the Earth.
Daniel is referring to a chap named Jonathan Zenneck, who died in 1959 after a lifetime study trying to figure out how to propagate power using the Earth's surface as some sort of abstract waveguide, using the ionosphere up there and the Earth down here itself. But don't get too involved in that, because your head will go literally into space itself. It is very complex. Nikola Tesla, you've all heard that name. He, who back in the very early part of the 1900s was working on a new way of transmitting radio waves, which rather than go out into space, as high frequency short wavelengths do, if you've got a high frequency, FM and so on higher than that, they go straight through the ionosphere into space. Instead, he wants a wave that hugs the ground, or surface ground wave, VLF, or very low frequency, and that's a very, very long wave. The sort of stuff used for transmissions to submarines and, of course, sonar. By the way, this Tesla is nothing to do with the electric cars per se, other than an electric name association, if you like. Nikola Tesla's study was carried over with the German Jonathan Zenneck, who also spent his life trying to figure out a way of propagating power, as in electricity, around the Earth. He eventually managed to push power across his bedsit, we believe, but that's about it, nothing further than that. The Zenneck wave is created by radio frequency, but it's not a radio frequency such as 96.5 Radio Bahrain FM, as I said. This is hard for a lot of us to perceive, I know. Now, these very low frequency waves also have the property of going very long distances on the surface of the Earth, if you put enough welly, or boot behind it, that is. We're talking of huge power now.
It adheres to the Earth. It follows the contour of the Earth. With the wavelengths that we transmit at, the Earth looks like a smooth round bowling ball or a smooth pool ball. So mountains don't get in its way, oceans don't get in its way, deserts, it doesn't matter.
It's almost pure 100% efficiency, isn't it?
Pretty close. We're forecasting somewhere around 85 to 90% efficient with the equipment that exists now. Once we get the equipment that we need, that we've told the designers on the different manufacturing companies that we need, we'll be in the high 90s.
High 90s. Well, explain that to the viewer. Now, the thing is efficiency.
If we generate 100 watts, we will deliver 95 to 97 watts.
Amazing.
And the current standards are on their long haul is somewhere around 70% of that. So if they generate 100 watts, they'll deliver 70 watts. So we're picking up in efficiency and reducing the costs, the capital expenditures that people have to make for their distribution systems.
And purely earthbound. There's no way you couldn't sort of set it up on the moon and bounce it down.
Yes.
No, it wouldn't work.
We could set it up on the moon, but it will only work on the moon.
That's the great thing about it.
Right.
So how much total power are we talking about? Now, I mean, in terms of, you've got to generate the power, you're just transmitting it. It's unlimited.
That's correct. We're only limited by the generation that we can have access to. There's a certain component to that. That's not the only component. I mean, this is a very complicated system to transmit. There's like 23 different variables you have to get right to have efficient transmission. So it's not an easy thing to do. In fact, it's nearly impossible. It's taken 40 years to get it to this point, but now we have it, and we have it patented.
It's a whole new dimension, pushing the wave around the entire world. And the Europeans, the Russians, the Americans have all been trying to figure out this for decades. Now the Americans have. Apparently.
They actually first launched the wave on the Earth in 2003. And so they've been working since that time period, perfecting it, doing tests, making sure that they had what they had the wave in a way that it could be utilized. The power component is one aspect of the breakthrough. Just like the first wireless was radio, but it's the same concept that radio has, all the way from television to satellite communications to wireless internet. All are on that technology and on that waveform. This waveform will have as many iterations of technologies that reside off of it, one of those being the transfer of power and commercial grade power over any distance.
Now, no doubt many a covert operator with interest will actually be watching facial expressions in this video to see if there's anything to be gleaned.
I'm sure people are watching us.
I mean, is there anybody else doing it, or only the company so far?
There are a lot of people trying. The Russians have been trying to do it for 50 years, but they've gotten nowhere. They're approaching it differently. We're not going to tell them any different.
As mentioned a few seconds ago, many theories have explored this phenomenon, each using the Earth and ionosphere as a directional wave guide. It's how radar works, in fact, or something like that. But don't dwell on it, because the boffins didn't get very far with it either. And this standing wave process is not directional, it's omnidirectional, meaning just as city radio stations, they go out in all directions around from the antenna simultaneously. It's not a beam like radar is. Of course, to have a cup of tea, you have to plug your kettle in using a wire. You'll still have to do that. Well, for now anyway. But around the Earth, nothing. And cable companies, well, they're going to have to seriously adapt or go out of business. So how do we figure out the length of a wave? Well, that's easy enough. The Greek symbol lambda, which is determined by the speed of a wave, or as scientists prefer to refer to it as velocity, divided by the frequency, how many cycles per second, easy enough, yeah? You get the length of the wave, literally, measured with a ruler if you like, from point 0 to plus, to 0 to minus, and back to plus again. In between, that is the length of a wave. Now, Texzon needs to launch a very low frequency, very long wavelength. Okay, getting the standing wave out there in the first place has been the challenge for over a century. Tapping it, getting the power from it, is another huge secret that Nupower nor Texzon are going to reveal anytime soon. Plus, once in place, just like trying to hack your Wi-Fi, the spies will be trying to hack the codes for this.
No, it's a very hard process to tap into. It's almost as hard to receive it as it is to transmit it. So in addition to that, it's subject to the same encryption and decoding that any other RF, radio frequency is subject to. So all the encryption, the data skipping, the frequency hopping, all the other technologies are directly applicable to this.
Speaking conventionally, wireless as a word is a bad analogy, because a standing wave, as in say an FM radio transmission we were talking about, which is electromagnetic, would be a disastrous situation. Without getting too technical, it would mean that the power transfer from source to antenna would be severely crippled. Standing waves can occur when there is a mismatch of wavelength with the conductor's length as required, or conduit if you like. A break, for example. Yes, it's complex. But just to know this, a Zenneck process, or the Zenneck process, needs a standing wave sitting on the Earth, all the way around, doing absolutely nothing, until someone pokes it. This process actually defies everything we've ever learned, and Ohm will be turning in his grave, no doubt. Conventionally, simply Earth is Earth and considered zero potential. That's just to make matters more complicated, that is. Though as with everything these days, not only fascist liberals, friends of the earth, tree huggers and boycotters of Robinson Jam, but everyone is going to ask the same question. Will we get fried if we walk near it?
No, it's very safe. It's actually more safe than the current standards. The current standards are 90% greater than what this will generate in terms of an RF frequency, which is how they measure the health and safety standards with respect to RF, or radio frequencies.
What about activism? You know, I mean, fracking and all that sort of stuff. This is so clean, surely.
Yeah, it doesn't have any impact. I mean, the sun is the biggest contributor to RF frequency in anywhere. It dwarfs everything else, and that is what the standards are set off, has to do with the sun. So when we're talking about where we're going to be in that component of RF exposure, we're way below the current standards that exist. So there really isn't any safety concerns. There's no shock hazard. There's none of the other things that would come, as you would think of, with electricity in the way this is being transported from the generation source to the receiving source. Once you reconvert it into power, then you have all your electrical issues of shock and those things. But those are all current things that you deal with in the substations and delivery from the point to your house anyway.
Of course, electricity for all intents and purpose travels at the speed of light, pretty close anyway, so near instantaneous around the Earth as it goes. We can't see it, but it's there. So what does this look like?
There is no beam. It's omnidirectional. It's just a standing wave that resides on the Earth that until you put a draw on it, there's no effect.
Well, it's getting frightfully complicated, isn't it? Well, let's see. We've all seen little dicky birds sitting on pylon wires, but they don't get a shock because both legs are sitting at the same potential or voltage pressure. Hence, current passes along the line harmlessly, harmless to them indeed. Now, if you touched that bird while you're standing on the Earth, you reached out for the bird and you touched it, well, you could both say goodbye. Bye-bye with a very, very hot flush indeed. The current is said to flow from negative to positive, or the other way around if one thinks conventional and semiconductor physics. It doesn't really matter, providing your circuit is the same throughout. Change it around halfway round and all sorts of worries you've got there. There is a thing called a potential difference between positive and negative. Now in reality, nothing actually moves as such. It's all charged particles. Current kills you, voltage will just burn you. Now one wonders that if this standing wave started moving, what would happen? Well, in theory, nothing. We are at Earth. Earth potential, zero potential, conventionally. It's weird, isn't it? So Bahrain wants this form of transmission, and obviously rich countries who can afford the investment, think quick, will really go for supply, building huge nuclear power stations to feed countries less fortunate that might be thousands of miles away. Of course, they'll make pots of money in the process. And not an expensive cable in sight. Imagine New York powering London, Bahrain powering the rest of the Gulf and beyond. Whoever gets in first with the investment. Who needs to sell oil after that? Send out the power and bring in the revenue. The potential? Oh, sorry, mind-blowing.
In theory, yes, you would do that, but I don't know why you'd want to do that, but you could theoretically do it, yes.
Well, if you run out of oil, for example, or...
but if a lot of countries don't want all their power coming from one place like Texas. You want it coming from a lot of different places around the world. So you don't know where the electron came from. We wouldn't rather have it coming from Brazil and Canada and Australia and have a mixed bag of
all right, we can have it from Manitoba.
Yeah, that's true too.
I mean, I don't mind. But the thing is, you're talking nuclear generation now. They've got its fission. Now, you've discovered this. You've got this far. What if someone tomorrow has to stand here and say, we've cracked fusion now, we've cracked fusion? Then you'd have one power station in the world, wouldn't you? You wouldn't need any more. They'd be billion, trillion, zillionaires, wouldn't they?
In theory, but they'd still need us.
To transmit it.
So we're happy too.
This is definitely the next big advance for mankind, and it is happening. Now, speaking with company chairman and chief executive officer Talal Mushler, we asked him, why no big media hype? There's no PR about this, no advertising campaigns. Why is it that the public are not ranting and raving about this? We don't even know about this. For one thing, these people are very technically minded. They're, a little bit off and a little bit more advanced than most of us. Talal answers with a sort of been there, done it all nonchalant look, looks quietly at it and says, well, we generally only ever have one client in every country. A statement that needs absolutely no further embellishment.
It's because it's by design. The company's been working on getting its patents in place for the last 4 years, and so we didn't really want to start moving into the market until such time as we had what we felt were the sufficient patents and patent pins in place, a sophisticated international setup, and a way to begin the process, because we know that it's going to be everybody wants it all at once, and that doesn't happen. But you just have to figure out how you're going to put your plan together to deliver this opportunity into the different marketplaces.
So last question then, you need me, really. You need the media at the moment. You're ready to put it out there.
We're starting to, there's going to be more, there'll be more things that'll come out into the media. They'll start later this year in the US. But there has been a holding back of media interviews and media opportunities.
We're lucky then. But there again, you've got a big job ahead, because everybody like me is going to be asking you such curious questions as what the hell is this going on? Right. So you're ready for that, are you?
Yeah, we're ready to start that process. So, and this is the beginning of it. But we want to start it in the right markets, because we need those people in the markets that we are to hear what we're bringing to them.
Yep, over 100 years in development and experiments, and now they have cracked it. Quite who they is and what it is, well, that hasn't been revealed yet either.
We've opened an office here in Bahrain to be the hub office to support the GCC area and the local market here in Bahrain.
So the office is in Bahrain?
Correct.
Well, I would think the rest of the Middle East would want you. This is a bit of a scoop, isn't it?
Yes, I mean, I think it's just the way that this is going to roll out in this marketplace. Bahrain is a good location for us. It's got a sophisticated leadership in the energy, who's forward thinking. It's got a good sized market that is stable, and a sophisticated energy market in terms of delivery. You don't have a lot of older systems that you're having to bring online. So it's got a lot of the precursors that we'd like to see in a market that we're entering.
How long have you been pitching here now?
We started getting the office opened in last fall, and so we've been here, and we just officially opened the office with the help of the minister on the first part of January this year.
Well, this is 2018 now, so last fall was 2017. Now, just to get that correct. So, really, how have you found the setup? Have you found everything? Because they talk about Bahrain being the easiest place in the world to set up business. It's been receptive all the way around.
Yeah, they've been very receptive. I mean, there's been, we felt there's a lot of support. A lot of support for this technology, a lot of support for what we're trying to do. It's really got a lot of elements that help mankind. And so those are all different benefits that the technology will bring into different marketplaces. So,
furthermore, the interest is extremely high.
Yeah, we've been very pleased. Middle East is very receptive to it. Everything is here that we need. They have the financial ability, they have the engineering talent, they have the political sophistication to know what they need and how they want to do it. Everything is here for us. It's just all we have to do is get here.
And the beauty of it, no environmental challenge anywhere, really, is it?
No, all the environmental issues have already been well documented. We just have to show how we fit into the existing literature. That's all we have to do.
Well, I wish between the two of you, Daniel and you, that we could actually show how this works to the layman, because it's so mind-boggling, it really is. But thanks very much indeed.
You're very welcome. Thank you.
Beam me up, Scotty.